Strontium-90 is a radioactive material that decays according to the function A of T equal to A sub 0 times e raised to the negative 0.0244 T, where T is measured in years. Assume a scientist has a 400-gram sample of strontium-90. What is the decay rate of strontium-90? Our decay rate we have here in the function. R is negative 0.0244. We also could express this as minus 2.44% if we want to express this in percent form. We know this because of the continuous growth equation. A is equal to P times E raised to the RT, where A is the future value, P is the present value, which in this case is called the initial measure, or the initial quantity. So present and initial when T is 0 would be the same thing. R is the growth rate. Well, in this case, it's decaying. So instead of a growth rate, we have a decay rate, which is negative. And then again, T is measured in this case, years. How much strontium-90 is left after 10 years? So we're finding A of 10, the future value after 10 years. That's going to be equal to the initial quantity, which in this case is 400 grams. And then we'll multiply that by E raised to the minus 0.0244 times 10. So we'll go 400 times second natural log. Now we're going to multiply up in that exponent, so I'm going to open a parenthesis and I'm going to put minus 0.0244 times 10. Close the parenthesis and hit enter. And we get 313.4 if we round to one decimal place. And that will be grams. When will only 100 grams of strontium-90 be left? Okay, that means then that we're going to plug 100 in for A of T. So the quantity at a given time, and we're supposed to find that time, when is the question, is going to be equal to 400 times E raised to the minus 0.0244 T. So we have to solve for T, so we're going to need to use a log expression to do that. So let's rewrite that. 100 equals 400 times E raised to the minus 0.0244 T. We'll begin by dividing both sides by 400. And we'll get 1/4 equals E raised to the minus 0.0244 T. And then we'll convert that to its log form. So the natural log of 1/4 is equal to minus 0.0244 T. We'll divide both sides by minus 0.0244. And then we will find T. T will be the natural log of 1/4 divided by minus 0.0244. Now that's the only way that we can express this thing exactly. If we wanted to estimate that time, then we can use a calculator. So we'll have the natural log of a fourth, we could type a fourth in there, or 0.25, same thing, divided by the opposite of 0.0244, which is going to give us 56.8 if we round to one decimal place. And that time was in years. The next question says, what is the half-life of strontium-90? The half-life is the time required for half of a sample to decay. So if we start with a 400 gram sample, then the question really is, how long does it take, or when will 200 grams remain? Our expression is A of t is equal to 400 times e raised to the minus 0.0244t. So the question is, when will 200 grams remain? So we'd have 200 equals 400 times e raised to the minus 0.0244t. We'll divide both sides by 400. And now we're going to have a half is equal to e raised to the minus 0.0244t. And we'll rewrite this in its log form. So we have the natural log of a half is equal to minus 0.0244t. And we'll divide both sides by minus 0.0244. And we will wind up with t is equal to the natural log of a half divided by minus 0.0244. And this is going to give us 28.4. 28.4 years.